Welcome back. Today I'm going to be going over this SAT geometry question. And once again, thanks to Anico.ai for providing this specific question in their free resources tab. But before I get started, please give this a try yourself. Okay, so here we have the triangle PQR is inscribed in a circle that has a radius of 65. So the length of PQ is 130, the length of PR is 126. And which of these answer choices equals the value of QR over PR? So first things first, right, for any geometry question, you have to draw a diagram. So let's draw a circle. And we know that the radius is 65. So we're going to have a radius of 65. Right, and the radius you can draw it anyway, right? Triangle PQR. So we know that's inscribed in the circle, right? Remember, inscribed means that all vertices of the triangle touch the circle and that the triangle is inside the circle. So the length of PQ is 130. All right, so we know PQ is 130 and that Q and then PR is 126. Well, at first, right, given what I told you about inscribed triangles, you might like say, okay, let's just draw a triangle where all three vertices are touching the circle, right? And let's say you took this approach, right? We have triangle P, Q, R. Then PQ is 130, PR is 126. Well, first of all, what I want to point out is that this diagram is actually impossible. The reason is, and this has to do with the title, is the length of PQ is 130, right? And you know that the radius of the circle is 65, right? So like this again, this is like 65, right? Center to any point on the circumference at 65. Well, if PQ is 130 and we know the radius is 65, well, what do you notice about those two numbers, right? You'll notice that PQ is 2 times 65, right? Because if you do 2 times 65, you get 130. So you know that PQ is 2 times 65. Well, that's 2 times, what is 65 in this case? 65 is the radius. So it's 2 times the radius. Now you have to recognize that if a chord in a circle, right, which is basically a segment that passes through the circle, if a chord in a circle is 2 times the radius, right, that has to be the diameter of the circle, right? So that's one important thing you should know is that first of all, the diameter in a circle is the longest chord, right? Diameter is the longest chord in a circle. And second, a diameter is 2 times the radius, right? So given that, well, you know that this diagram can't be possible because PQ has to be the diameter, right? But it's clearly not in this case, right? Because the diameter passes through the center. This one clearly doesn't. So what that means is you have to redraw your diagram. Right? And I'm going to remove the radius, right? We know it's 65, but again, I'm just going to remove it because I'm going to show you what the actual diagram should look like. So if PQ is the diameter, right, that means you have to draw a segment that goes through, and we call this PQ, right? And once again, we know that's 130. We know PR is 126. So R, where would R be, right? R could be anywhere. I'm just gonna put R here, right? Again, R could be here, it could be here, it could be anywhere. but I'm just going to put R here. So now they tell us PR is 126. So we have PR is 126. And of course, we don't know the length of RQ. So we're just going to call that X. So now we have a triangle, and it's technically inscribed in a circle, right? Because all the vertices are still touching the circle, right? And the triangle is inside. Well, how do you find that missing side, X? An important thing to know about a circle, right? This is like a property of a circle, is that if the hypotenuse, right, or if a side of a triangle, right, is a diameter in a circle, then the angle opposite that side has to be a right angle, right? Like if the point is touching uh, the circumference of the circle, right? And you might be wondering, well, why is that the case? Well, think about this, right? This is half the circle, right? Yeah, we have one half over here, and you have the other half over here. So you could think of this, right? This specific arc length here, and remember that a circle is 360 degrees. So you know that this angle here has to be 180 degrees, right? Again, I'm referring to this angle. Well, if that angle is 180, then an important property about circles is that any inscribed angle, right, as you can see here, is going to be half, right? It's going to be half the uh, angle of the arc, right? Or the measure of the arc. It's going to be half the measure of the arc. In this case, because the arc is 180, well, half of that is 90. So that's why this is a right angle. So now that we've kind of leveraged that fact, right, for this problem, we can go ahead and actually solve the missing side, right? Because now we know this is a right triangle. How do you find x? We'll use a Pythagorean theorem, right? Once again, this side is 130. So you have x squared plus 126 squared equals 130 squared, right? And of course, right, we look at the positive solution, x equals 32. So now we know that x equals 32. How do we find QR over PR? Well, QR is 32, PR is 126. Simplify that, you get 16 over 63, which gives you answer choice C as your answer. So, the most important thing about this problem is to first recognize that PQ is actually the diameter of the circle. And once you do that, right, then you have to also recognize that this is a right triangle and you can solve for the missing sides from there. So hopefully this made sense. And if it didn't, of course, leave any questions you have down in the comments. But thanks for watching, and I'll see you next time.